Welcome. Thank you so much for coming and listening to your only choice at the Single Track Conference. Just realized that. So I'm going to be talking about serverless and CatOps, trade-offs in operations and instrumentation. My name is Pam Selle. I'm at IOPipe. You can follow me on the internet at Pamasaur. My blog is thewebofwar.com. A little bit about me. I am the software engineering lead at IOPipe, where we build monitoring and tooling for serverless developers and operators, and a few other things going on, Google Developer Expert, Recurse Center alumna. I also have 2 cats. So I was led to believe that cats are the easy pets. They're super adorable. See, aren't they so cute? There's a little like twitch. Oh, yeah, that's really cute. So they're really cute. They mostly take care of themselves, right? Lies. These are lies. So to talk about my roommates for a minute. So this is Luna. Among her hobbies, she likes to knock over water bowls. She's also not, cats in general aren't super great at drinking water. This is like a thing. And so she's had to go to the vet for that before. She's also, she's less so, but she's a bit chunky. So she needed to slim down a little bit. And then the other one, we've got Terrapin. She's a tortoiseshell cat. That's why it's Terrapin. It's like a turtle. Anyway, it's really cute. So she has some issues where she has urinary issues, which is a nice way of saying she sometimes peed in my apartment unpleasantly. And so she has special prescription food. She's also a little bit smaller than Luna, but also dominant. So she will, given the opportunity, eat all the food that's there, and Luna won't have any, and it's gross and bad things happen. So that's my furry roommates. And then this is how many days that I've spent away from home in 2018. It's June now. That's not including me being here right now at Monitorama. So I'm away from home a lot. And so I've developed some systems on how to keep my cats happy and healthy while I'm gone. Because it's okay, I've developed some systems. If I had paid for a cat sitter for every single day I was gone, it would be just those 43 days, and that's not even extended into last year when I started adding some of these things. That's about $700. And so I was thinking about how the decisions that I've made around my cat setup is kind of the term that we call, the people I work with kind of like we end up having these systems, and this is what we call it CatOps. And I think about how this is a lot like the way I approach and how I feel about serverless computing. And so that's what I'm going to talk about, is 4 lessons on serverless DevOps as told through the lens of cat operations. And here's a cat belly to let you know that we're ready to get started. So lesson 1, being punt to the platform. So when I think about what I want in terms of what I need to care about in terms of my care of my cats, I want them to be fed, I want them to be healthy, I want this feeding to happen on a schedule, I don't want to have to be there. These are the concerns that I have. And so that's why, with a little bit of self-loathing, I went ahead and just bought an automatic feeder. If you have not yet seen a conference talk about someone's very cool Internet of Things cat feeder, there are a few of them, and you should go watch them. They're really neat. Meanwhile, for me, my Internet of Things experience is a literal sack of electronics that I've accumulated over the years and have never completed a single Internet of Things project. So there's just some, it's really healthy to be honest with yourself. And given what I care about is that I care that my cats are fed on a schedule, reliably, that happens when I'm not there. Why in the world would I trust myself to build that Internet of Things system, given my track record? And so that's what I think about in terms of with the self-loathing that I just went ahead and bought one because it solves the problem given what I care about. And that's how I feel about serverless compute. And this is the AWS logo, AWS Lambda logo in the corner, if you aren't familiar. That when teams decide to, application developers in particular, decide to move to serverless compute, they're thinking about how can I let the platform solve the problems that I don't want to have to worry about. I don't want to have to worry about server configuration. I just want to write business logic that solves the problem that I'm trying to solve and move on. And this is one of my favorite serverless quotes, so I love to pull it out, from Matt Wood at AWS, that no server is easier to manage than no server, in that people go to the serverless. Yes, obviously they're servers, get over it. But the concerns that you have in terms of operating in a serverless environment are offloaded to the platform. That's the AWS or whatever cloud provider I choose in serverless is going to be the one to spin up my containers for me, to apply security patches, do all that important stuff that it's honestly somewhat of a solved problem. Or, it depends on what problem you want to be solving. And so to back up a little bit, just to make sure we're on the same page about serverless, when I talk about serverless, I'm talking about, in general, in this talk, I'm talking about functions as a service, which is running code on demand in response to a defined trigger. That means that your code is uploaded into storage, and then it gets triggered as you have some event that flows through it. And this makes me think about how, much like cats, it's an event-driven system. I can't control when my cats are going to do things. And so I want my system to, in general, in terms of the feeder's a schedule, but in general the system kind of exists as the cats exist, and it's generally all pretty good. In the same way, I don't want to, or I really don't want to, honestly, control the event flow in my event-driven serverless architecture. And that's really where serverless compute shines, is in these event-driven architectures. If you don't have an event-driven architecture, you probably shouldn't be using serverless compute. In terms of functions as service providers, it's available on pretty much every major cloud. Just going through some of them here, you've got Google Cloud Platform, I believe, is here at Monitorama as well. So it's this way of running compute. It started in 2014 when AWS released Lambda, but in just less than 4 short years, it's becoming ubiquitous across clouds. And in terms of deciding which one I went with in terms of my feeder, I wanted to say is highly reviewed, cat meddling proof. If you have cats, this probably makes sense to you, because a cat feeder is kind of pointless if your cats can break into it. They're like, Ocean's 11 mastery. And so I cared that if I'm going to spend $100 in a feeder so that I'll get the benefits of it, I want to make sure that it's actually going to solve my problem. I also cared, and I thought about some security models for my cat feeder, is that I didn't want it connected to the internet, because I didn't want a feeder to become part of the Internet of Things botnet. I also got paranoid and didn't want someone to be able to attack me through my cats. So I don't know, it could happen. And also battery powered, so that if there is a power outage or things, the point of this is that I'm away from home, so I want this to have power even if, say, something happens to the grid. And when I think about AWS Lambda, highly reviewed, a few of you might have heard of AWS. So you also benefit from the AWS ecosystem. In terms of running serverless compute, it's an event-driven system, so you're going to end up with a little bit of that kind of hairy architecture diagram where there's lots of lines connecting things. And in that way, it's very handy to be in AWS, because you do have all these other tools like your data storage, your streams, your queues, that you can use to connect these systems together. And of course, tooling. As the largest serverless functions as a service provider, AWS Lambda tends to be the place where most tooling shows up first. This is becoming less true, I would say, because, say, Serverless Framework is a really popular framework for the configuration as code approach to deploying serverless applications, and Serverless Framework is multi-cloud. So that is something to think about. Lesson sub A of punting the platform is thinking about cost. And this is one of the big reasons people end up moving to serverless, and it's one of the big reasons why I automated some of my cat care, is that the cost of caring for my cats is food, litter, vet, sitter. And those last two are the things that I have a bit more control over. And so by automating the food and watering of my cats, I can reduce my vet bill and also my cat sitting bill. And cost in a serverless environment is the combination of compute time, invocations, and network, where invocations and network can vary on whether you are charged or not by them on the cloud provider. And this is a little bit of information about the pricing tiers on AWS Lambda, if you're curious. You do have a generous free tier. And so in terms of if you are not as familiar with serverless and you're interested in checking it out, it's very accessible to do so. I always love looking at the price per invocation because it has 6 zeros in front of the 2 after the decimal point. And so it can be very cost efficient to run, just as I found that buying a cat feeder saved me hundreds of dollars. And in terms of compute time, wrapping my head around GB second is something that I like to take a second to parse out. So a GB second is the measure of compute time, where it's 1 second with 1 gigabyte of memory provisioned. So if you provision your function to use more memory, you use more compute. Your compute's more expensive, and so it becomes advantageous to think about how you can run your code at lower tiers if it's accessible to you, or to think about right-sizing your Lambda functions, which is a problem that people are still exploring. It's not as solved as it could be. Lesson number 2, know the limits. So my cat water fountain lasts about 5 days without adding fresh water. So the cat water fountain has a nice big well. It has a pump so that it's pushing water from the well out so that it can actually get pretty low before anyone needs to add fresh water. In a similar vein, in AWS Lambda or in serverless environments, there's some hard limits. So these are specific to AWS Lambda. If what you need to do does not fit in these limits, then you don't get to use this. So things that are long running, things where if you run into the limits of your memory tier, you get that spiky chart. Because when you run into the limit of your tier, you're going to run out of memory and you get what we call a cold start. So your function gets kicked to a new container. And to some degree, you can keep going on that path. But that's why right sizing is definitely still a thing people are working on. And in terms of understanding those hard limits, some of the things that we do on our team where we run a lot of serverless is we always do acceptance tests on the provider. We don't rely fully on emulators. So of course we use emulators because we want to do local dev and test, but when you are punting to the platform, there's really no substitute for running acceptance testing on the provider and doing kind of performance testing in the environment that you're going to be running in. And that in terms of limitations, I would always say the biggest gotcha or hazard in serverless compute is letting serverless compute play with things that don't scale in the same way. And that means that using appropriate layering between your serverless functions, your AWS Lambda functions, such as using queues or streams between them and less scalable resources, or even between each other so that they can't attack each other, is generally a really good idea. Lesson 3, exposing system status, or how we keep an eye on things. So this could be better in cat operations. I call this eyewitness observability. There's a clear view where I can see where the food is, and then I put more food in pretty much every other week. It could be better. But it'll be more interesting to talk about serverless for this. We think about what we want to observe before and after your function's in the wild. The classic observability problem applies. We don't know what's important until we know it's important. But we have some things to try and mitigate that. So to that degree, I'll talk about one of our important systems. So at IOPipe, we run monitoring and tooling for serverless developers, and so we also run serverless applications ourselves that are doing those things. So our alerting system, we call it Whistler, it is run on an n-minute timer, and so it has these 2 functions that are running. That's the core of the system with some layering around it. So the schedule function gets alerts that are configured, so the rules that exist in the world essentially, and creates queue messages that we pop off to the execute function. And what the execute function does is it investigates those rules via the data store, and it reacts appropriately, whether that means that an alert has resolved, or an alert has been triggered, or various states that things can be in. So we use IOPipe to monitor our IOPipe alerting service. And we think about what states alerts can have, And we use a few different tools in our tool belt from our agent libraries that are open source to expose that observability later on. So I have some, so I have some screenshots in case this fails, and I'm going to show you our production dashboard. So let's do that. All right, don't worry, that's supposed to be an alarm. So it's like I've been prepared for that. I was like, don't worry, sorry, it's supposed to be an alarm. All right, so I'm looking at our function, and I'm going to open the window a little bit so that I can see some more labels. Okay, yeah, because this is our live running alerting system. And so we label, so this is so we think about, especially running serverless, we have this pile of invocations, essentially. There's just, each invocation is this little thing that happened, but how do we make sense of it, and how do we make sense in context? How do we make it part of a story versus just an invocation that happened? And so one of the things that we use is labels. Let's see. Yeah, there's some labels. So this one, so we labeled the invocation. So it means that inside the invocation, and I'll show the code for that, we configured and we said, we made a decision in the business logic, which is, it feels like the very serverless thing to do, right? If we're moving the focus toward focusing on the business logic happening in our serverless function, then that's exactly where we're going to put some information to expose to ourselves outside. So we can send notification, should generate event. So this is, and we have some tracing going on. We have some custom metrics. And so I can say, OK, I'm going to look at that alert ID so I can see all other invocations that are related to this alert. So how many invocations have been related to when we've investigated this alert in the execute function. And the invocation view has some information about duration, memory, CPU, the kind of systemsy useful things to know when you're trying to investigate something. So I'll jump back. And then I just put some, oh yeah, there it is. So that's the code so this is Node.js. And that's what Whistler is. This is a more generalized example. So it'll be very easy to read. But you can put in tracing marks, you can apply metrics and label things from inside your Lambda function. And so there's some screenshots for reference so if you're looking at this later. Some limitations in overcoming them. Classic observability problem, we don't know what we want to know. We have been working on this and solving this by thinking about the business. So thinking about I think about it in like the human readable story of what happened in the function. So did this function send an invocation? Thinking about what the system is supposed to do and then saying what it did. Versus, of course, tracing for, oh, I talked to the database. Oh, I talked to this API. Yeah, so we do that. It also is work to think about this, to think, oh, I need to put a mark when I'm going to call the API and then end the mark after I call the API. So auto instrumentation is a thing that we have been working on, and I think I'll probably have some time to show the early version of that. So when in doubt, you can also throw containers at the problem. So for the other cat thing that I have yet to address, I just have a bunch of litter boxes. There's fun facts, cat facts. If you have cats, you're supposed to have n+1 litter boxes. So if you have 2 cats, you should have 3 litter boxes minimum. So to this degree, this is one of the things if you might have thought, I mean, hopefully you didn't, but maybe you thought, how do you go for 5 days without scooping the litter box? That's how. They just have more of them. And this is back to the parallel to serverless compute. Functions of service are flat scaling. Luckily, my litter boxes aren't, because that would probably get pretty gross really quickly. To some degree, because serverless is ultimately still, it's a newer kind of cloud compute. You can throw many different kinds of problems at it that it will work on. And to some degree, for some of the problems, containers will solve it. Assuming you don't run into your concurrency limit, when you send an event to AWS Lambda, what it does is it's spinning up a container in response to that event, or reusing the container if there's enough of a gap. So let's say we have event 1 comes in, and event 1's not done yet. So event 2 comes in, a new container. You'll incur the cost of a cold start, which we mentioned earlier. But depending on what your workload is, maybe that's fine. And we have seen people run workloads on serverless and AWS Lambda where they're running into they run out of memory or they run out of temp directory storage and they get a cold start. And for whatever the workload that they're doing is, maybe that's fine. If you're not running a synchronous API service, maybe that's fine. So to some degree, you can throw containers at the problem. And also, I felt like it was a really easy joke to make it Monitorama. So as to what's next, how can we increase visibility in cat operations? Definitely real monitoring would be good. I already confessed to you about how I failed at all of my Internet of Things. I have an Internet of Things project related to cat operations. It's not done. But it's related to I want to have monitoring around when I need to put more water in that water fountain because that's not as visible as I would like to see. So I want I have a scale sensor that I'll be hooking up, and all these things will happen one day. Also, health checks on systems, photos and computer vision would be really cool. Since the feeder is on a schedule, I know what time the food is supposed to come out. So I can set up monitoring so I could see if it came out. And also, since it comes out on a schedule, the cats run to it when the food comes out. So I would actually be able to see the cats. And of course, alerting. Dashboards, there should definitely be cat dashboards. Mood monitoring, especially for the moody tortoiseshell cat, also probably a good idea. Kind of like I think about if you ever played The Sims, like their happiness levels, I would really like to know that. And in serverless, identifying duplicates. So this is something that we do actually have in our data right now, and we're working on exposing the visibility of it. AWS Lambda guarantees at least once execution. Hooray, distributed systems. So that means that sometimes you might get more than one, and that there are duplicates, and then there are also retries. So if your function errored or ran out of memory, depending on how you've configured your function, you might have retries. So we want to take invocations and be able to understand when something is a duplicate or a retry, and also create a relationship between those invocations so that those are easy to navigate those records. Some auto tracing of HTTP calls to move from visibility to automated visibility would be really cool. Actually, I'll go ahead and jump into showing that. So I have actually this is a local copy of our app that I'm running. And so this is, we're actually running this on staging because, yeah. Why not test in staging? And so we have a tracing, and so this is actually hooking into HTTP events and saying, you notice that this is actually a configured trace. So this get rule results, and then this is the HTTP call. So you notice there's a little bit of difference of the HTTP call versus the mark that measured it. And then the metadata, this is very, very fresh, and so we're working on this right now. But that will actually automatically trace all HTTP calls in the application. Also interested in a runtime agnostic wrapper. So right now we have open source agents for Node.js, Python, and Java, and Go is in alpha right now, Golang. And while we love having agents and being tied, we also want it to be easy to read the agents for people who are using it, because we philosophically believe that if you're going to wrap your code in it, you should probably read it. So, or you should be able to at least. And something we're interested in is a runtime agnostic wrapper. So if we can, instead of having these libraries that let you wrap your functions, how can we create a runtime agnostic wrapper so that we can support more runtimes more easily? We're also thinking about mutable instrumentation from outside AWS, from outside Lambda. So right now, there are a few things. Say you want to change, let's say, so we have a profiler that you can run on your AWS Lambda functions. And so you want to turn the profiler on, because you probably shouldn't always have the profiler on. But when you turn the profiler on right now, you have to do that via an environment variable. And that means that when you turn it on, you're going to get a cold start. So that means that in order for that to apply, you have to incur a cold start. What if we can have mutable instrumentation so that you can change the configuration from inside your function so that you aren't going to incur a cold start when you change configuration? So that's something that we're definitely thinking about. If you also are into weird cat stuff, there's lots of weird cat stuff out there. There's a laser toy that'll play with your cats for you. There's a feeder that reads the microchip. reads a microchip in their back or an RFID collar so that if you have an aggressive cat that they can't get the food and the other cat can. I actually have a friend with that, and she says it's hilarious. And if you want to see someone who's actually made cool Internet of Things cats, there's a very recent talk. This is from Bang Bang Con this year, so it's only 10 minutes. It's super cool. He made a system that takes cat selfies, so trained the cats to hear a noise and come running, and then it takes a picture of them and gives them treats. So yeah, it's like a health check for cats. And we also have a project for servers.lol. Yes, I have stickers. So this is a fun little project that you tell it about your EC2 infrastructure, and it will say whether you can or could, or whether you would or would not benefit from running on serverless. It's also a serverless project itself that you can deploy to your AWS infrastructure that will do this audit for you. So it's just a fun project that we built. And with that, I will adjourn. If you would like to chat with me, I'm at Pam Selle on Twitter. There's some information about IOPipe, and that's Terrapin sitting on my computer. Thank you very much.